Alrighty guys, but let's get into our lesson for today. So like I said, we're doing the converse of Pythagoras. Okay, so the converse of Pythagoras allows us to prove that a triangle is right angled. Allows us to prove whether a triangle is right angled. Alrighty, so remember that's the whole point of Pythagoras, right? We're working with right angled triangles. What's really, really important though is that we need all three sides of our triangle. Right, that's the only way that we can prove that a triangle is right angled or not. We have to have all three sides. So unlike Pythagoras, where I gave you two sides and you had to work out the third, you could only do that because all of our triangles were right angled triangles. However, now we don't know if it's a right angled triangle, we need to prove it. Okay, so again, the converse theorem of Pythagoras allows us to prove whether or not a triangle is right angled. And to do that, we need all three sides of our triangle, help if I could spell all, in order to prove that it's right angled. All right, so I'll leave this here, but we're going to have a look at an example. What I am going to do though is just move it down so that we're not wasting space. So if we have a look at this first example here, we've been given triangle XYZ, and the question specifically asks us to prove that XYZ is a right angled triangle. All right, so what we need to do is we need to identify our longest side in the triangle. Now, the reason for that, remember, typically we know that our hypotenuse is the longest side. And now we need to identify it so that when we use the Pythagorean theorem, we know what we're substituting in where. Okay, so grade 8's quickly on the chat. Which side in this triangle is the longest side? Let me know what you think in the chat. Which one is the longest side? Oops. Nice, grade 8, well done. Okay, so some of you have said 20, some of you have said XY, both are absolutely fine. What we see is that this side XY is the longest side in my triangle. All right, so what that means is that if this is a right angled triangle, that will be my hypotenuse. But now I need to prove it's a right angled triangle. So just as a quick reminder, Pythagoras says that our hypotenuse squared is equal to the sum of the square of our two other sides, right? This in the bubble here is the theorem of Pythagoras. And we now want to use this to prove that it's a right angled triangle. So how do we do that? Well, in order for us to prove it's a right angled triangle, to prove it is we essentially need to prove that the left-hand side is equal to the right-hand side. Okay, now when I say left-hand side, right-hand side, this h squared is on the left-hand side of my equation. The a squared plus b squared is on the right-hand side of my equation. So basically what we want to do is we want to prove that my equation is actually true, that my equation is balanced and that the left is equal to the right. Now guys, we do this through substitution. Okay, so we've identified what my longest side is, and remember, technically, if this is a right angle triangle, that would be my hypotenuse. So my longest side of 20 centimeters, I'm going to substitute in place of the hypotenuse. So 20 squared is equal to, and remember, it doesn't matter what order you substitute in the other two sides. I'm going to say 16 squared plus 12 squared If you had said 12 squared plus 16 squared, that's absolutely fine. Doesn't matter. Now, what you'll notice is that all of our values are substituted in. So it's not that we're solving for an unknown. We are trying to prove, as I've written here, we are trying to prove that the left-hand side is equal to the right-hand side. So we need to actually go and work out these values. So 20 squared, which is 20 times 20, is 400. 16 squared is 256. And 12 squared, we know, is 144. Right, so on the left, we still have the 400. There's nothing being added or subtracted there. But on the right, I've got 256 plus 144. And if I add those two numbers together, I end up with 400. Now, what I need you to see here is the fact that what we have shown is that the left-hand side is equal to the right-hand side. And so because the left-hand side is equal to the right-hand side, the triangle XYZ is a right-angled triangle. Alrighty, so when we are going to use the converse theorem of Pythagoras, we are checking, or we're trying to prove, that the left-hand side is equal to the right-hand side. We need to identify which is the longer side in our triangle, because that is what we will substitute for the hypotenuse. And as long as you can show me that the left is equal to the right, as long as you can show me that the left is equal to the right, you have correctly, or you have been able to prove that the triangle is right angled or not. Okay, we'll do some examples later where it isn't going to be right angled. But that is essentially how we do the converse. Now remember, this is a geometric concept, so we have to have a reason. So right at the start of my working out, instead of our reason being Pythag, we quite literally just say converse Pythag. Okay, so this reason is only used when we're trying to prove a right angled triangle. Otherwise, if it's normal Pythagoras calculation, so you're working out the length of a side, you will just use Pythag. Converse is only used when we are proving a triangle is right angled. All right, grade 8. So let's take our screenshots. If anyone has any questions, now's the time to raise their hand and ask. Otherwise, we're taking screenshots and then we're going to have a look at another example. Remember, guys, you keep your questions on the chat throughout. So if you have a question, you're welcome to put it in the chat. We don't just randomly raise our hands. You can put your question in the chat and I will answer it as we go along. So again, if anyone has any questions and they would like to raise their hand, now's the time to do it. Or you can put your question on the chat. Otherwise, I'm moving on to another question. Okay, so Lyndall, remember we say that, or we say left-hand side is equal to the right-hand side because that's what we need to prove. Okay, we have to show left-hand side is equal to the right-hand side. And so I have to make the statement that I have actually gone and proven that. And so therefore, it is a right-angled triangle. That was what I was trying to show. And so once I have actually shown that it's equal, we need to state, okay, cool, now I've shown you the left is equal to the right. So now I can say it's a right-angled triangle. Lomso, okay, so then it wouldn't be a right-angled triangle. We'd have to make it clear that, we'd have to make clear which side is the longer side. It technically then is isosceles, technically then can't be a right-angled triangle. It could be, but no, it couldn't be. Sorry, I'm just talking of myself in circles. It wouldn't be possible. You would have to have one side as longest, otherwise you're not working with a right-angled triangle. Yes, guys, LHS means left-hand side equals right-hand side. Yeah. Yes, it is possible. And I did say we would do some examples just now where the left-hand side is not equal to the right-hand side. We will get there. But it is possible. Now, lady, I did answer that question. You can have two sides that are equal, but then the third side must be the longer of the three sides. If it isn't, then it won't be a right angle triangle. It then is not possible. Okay, so we will give you questions where it's clear which is the longest side. Gabriella, we're not doing something new because as I've explained on Monday and today, this is still Pythagoras. We only move on from Monday. Exactly. So guys, when we do converse, we never have to use the square root. We're just trying to prove the left is equal to the right. Sean, no, you can only do Pythagoras, guys, on right angled triangles. Remember, I said this at the start. Pythagoras only works on right angled triangles. Right, I'm hoping we've taken our screenshots. I'm hoping that everyone has asked the questions that they need to ask. There were some hands that went up and some hands that went down, so I'm hoping that your question was then answered. And grade 8s, please remember that the chat is for answers and questions only based on the work we are doing right now. If you distract and if you put other stuff on there, we will remove you. All right, so let's have a look at a second one. So the second question says, show through calculation whether the following triangles are right angled or not. And we have a few triangles, but this is the first one that we need to look at. Okay, so remember the first thing that we do is we identify the longest side. So grade 8, so which side is my longest side here? Nice, well done. Excellent, guys. So exactly 26 meters is my longest side. Pen's a bit aggressive, but it's fine. We'll change it now. Once we know which is our longest side, we can substitute in. Now remember, it's hypotenuse squared is equal to the sum of my square of my two other sides. That's Pythagoras theorem, or the Pythagorean theorem. So now we're going to substitute. Remember, your longest side substitutes in for h. So we will have 26 squared is equal to, and again, it doesn't matter what order you now substitute in the other sides. You could say 10 squared plus 24 squared, but you could also say 24 squared plus 10 squared. Now, guys, remember, we have to give a reason. So this is now converse Pythag. And remember, I don't need you to write out Pythagoras. Pythag is absolutely fine. Okay, so now we go and prove. Remember, we're trying to prove left-hand side equals right-hand side. So 26 squared exactly is 676. 10 squared is 100. And 24 squared is 576. If we now add 100 and 576, we get 676. And what you hopefully see is that my left-hand side is equal to the right-hand side. And because they are equal, we can therefore state it is a right angle triangle. Okay, and that is the purpose of our converse Pythagoras. Naledi, just let me know more or less where you need to repeat. When I saw your message pop up, what I remember saying was the substitution, but just let me know where you need me to repeat from. Okay, guys, if we do have it, let's take our screenshots and remember, questions in the chat. So Naledi, I'm just waiting for you to let me know where you needed me to repeat from. Okay, so once you know the longest side, so we're happy that this is the longest side, that is going to be substituted in place of h squared. So that's why we've got 26 squared. From there, remember, we have to substitute in our other two sides. It makes no difference which side is A and which side is B. So if I consider 10 meters to be side A, I substitute it in. And then if we consider B to be side 24, we substitute it in. And then we can go and work from there. So all I was trying to say is that for the hypotenuse squared substitution, so for the h squared substitution, you have to substitute in the longer side. The other two on the other side, it doesn't matter. So Mila, if the side angles, yes, okay, sorry, I'm now on the same page. Yes. So Mila said if the sides are equal, it's right angled. Just be careful when we say the sides are equal, the left-hand side of your equation is equal to the right-hand side equation. Yes, if that is true and you've proven that, it is a right-angled triangle. Absolutely. Namandla, you can't simplify 676. It's as simple as it gets. Okay, so we can't actually do anything more than that. So once you've squared it, you're done with it. Leto, exactly. If the left-hand side is not equal to the right-hand side, it's not a right-angled triangle. We will do an example like that. I actually might just do that example next. But exactly, if it's not equal, not right-angled. All right, guys, so let's actually do an example where it's not going to be a right-angled triangle, just so that you can see how it would happen and what you will see. Sibongo, exactly. I'm going to show you one where they're not equal, and so not a right-angled triangle now. Oh, golly. Okay, so let's say we have got the triangle. Let's just get our triangle going here. Hello. I'm trying to draw this as well I can, but it's really not gone too well. Okay, so here's my triangle, and we want to prove if it's a right angle triangle. So let's say this is okay. So let's say I've got this triangle, and again, I've asked you to prove whether or not this is a right angled triangle. So what we need to do is the first thing that we need to do is identify our longest side. Hopefully we can all agree that our longest side is going to be the side 21 here. Alrighty, so remember, hypotenuse squared is equal to a squared plus b squared. That's what we're sort of working on here. We now need to substitute in. The longest side always substitutes in place of the h squared or the hypotenuse squared. Right, so we've got 21 squared is equal to 18 squared plus 9 squared, and we give our reason converse Pythag. Alrighty, now we go and simplify. So 21 squared is 441. 18 squared is 324. And 9 squared is 81. Okay, now I can't do anything more on the left. It stays 441. But I can add together the two numbers on the right. So 324 plus 81 gives me 405. Now, guys, those two numbers are very clearly not equal, right? 441 is not equal, or at least not the same, to 405. And because of that, we can now make the statement that the left-hand side is not equal to the right-hand side. So this symbol of the equal sign with a line through it means not equal. And so because the left-hand side is not equal to the right-hand side, we can therefore say it is not a right angle triangle. Okay, so either you get that the left is equal to the right and it is a right angle triangle, or you get that it's not equal and so it's not a right angle triangle. All right, there was a couple questions. So let's say in the exam, they say we must prove the triangle's right angled or not, or we have to show the calculations. Yes. Whenever you do a proof, you have to show your calculations. So everything that I'm writing down here, so everything over here, you need to write down in order to prove it. Absolutely. Nukukanya, I'm not too sure what you mean. So you said, how is that one not just Pythag? It's not just Pythag because remember, you're trying to prove it's a right angle triangle. It's only if I give you that a triangle is right angled and you're looking for a side, is it just normal Pythag? The second I say prove that this is a right angle triangle, you automatically have to use converse. Hope that answers your question. Nomkutano, h squared is hypotenuse, and then the a and the b are just the other two sides. So this could be side A, this could be side B, or you could swap it around. It really doesn't matter. It's just a very general formula of Pythagoras. Okay, there's a question of, will they ever say that all three sides are equal? Guys, you should know that if all three sides are equal, you have an equilateral triangle. And in an equilateral triangle, all three angles are all equal to 60 degrees. If all of your angles are 60 degrees, it's not possible to have a right angle triangle. So you just need to go back to your geometry and the triangle discussions that we had and just refresh that, okay? Right, I've explained h squared, a squared, and b squared, so let's just focus. Robbie, I haven't actually asked for a hand, but yes, what is your question?
Hi, I was asking, can you please repeat it again, because my phone was not showing the screen. So
okay, I'm not gonna repeat it again because you just need to go and watch the recording. We're going to do quite a few more examples, so hopefully it'll make sense. All right.
All right, thank you very much.
Right, guys, so I would tend to agree. Let's try one by ourselves. Okay, I'm just going to go here. Please take a screenshot if you haven't already done that, and then you're going to try one by yourself. So Ravi, give it a try, but when I explain it, just listen really carefully as I explain it, and hopefully it'll make sense of what to do. Is it possible that the triangle has decimals? I mean, it is possible, absolutely. We don't, I don't want to say we don't work with decimals because we do. Yeah, it is possible. When we're proving, we probably won't use as many decimals, but it definitely is possible, yes. Okay, guys, so let's try the second one. What I'm going to do is I'm going to leave the working out from question 1 that we did, just so that you can see what's happening. You're going to try question 2. Remember, first things first, identify your longest side. So our longest side here is the 15 centimeters. We need to know that, so we substitute in place of h squared. Right, so let's give this one a try. Yes, if we can have fractions, we can have decimals. So yeah, we can have fractions. Nomkatano, you just need to wait because I did give you time for screenshots. So I'll go back once everyone has tried this one later. Okay, so remember, you're trying to prove whether or not the left is equal to the right. like what I'm seeing so far in the chat. Let's keep it coming. Yes, it is a must. You have to give a reason. It is like it's a geometry proof, or it's a geometry theorem, so you have to give the reason. So remember, in geometry, we always give reasons for our statement. It's the same thing here, we have to. Oh. Okay, nice, guys. This looks good. Well done. Lost my pen. Found my pen. Righto. So let us have a look. And then, Robbie, like I say, have a listen to what I'm doing, and hopefully it'll all make a bit more sense. Okay, so guys, we've identified our longest side. So that's what we are going to substitute into our equation in place of h squared. I'm just going to keep writing the Pythagorean theorem, and hopefully it'll just, you'll be dreaming of the Pythagorean theorem at some point. Right, so longest side, 15. So 15 squared is equal to 12 squared plus 9 squared. If you said 9 squared plus 12 squared, that's fine. You have to put the reason. If you don't put the reason, yes, you will lose marks. Converse Pythag. Right, 15 squared, 225. 12 squared, 144. 9 squared, 81. If you add them together on the right-hand side, so 144 plus 81, you get 225. And because the left-hand side is equal to the right-hand side, because 225 is equal to 225, we can say it is a right-angled triangle. Okay, so guys, when it is equal, so when the left is equal to the right, it is a right-angled triangle. If they are not, then it is not a right-angled triangle. Okay, so let's take our screenshot. If anyone has any questions, now's the time to raise your hand and ask. I'm going to quickly go back to the last question that we did for those of you that need to take a screenshot. Robbie?
Hi, ma'am. Where do you get 225 before
that comes from the 15 squared. 15 squared gives me 225. 12 squared gives me 144. And then
all right.
9 squared gives me 81. So they've all come from the squares.
Okay, thank you, ma'am. Now I understand. I just wanted to understand that part.
Good.
Yeah.
Well done. Okay, so guys, there was a sort of a statement / question. So basically, both answers have to balance in order for it to be a right angle triangle. Absolutely. Okay, so it has to be equal on both sides, then it's a right angle triangle. Okay, so I hope you've all got your screenshots. I'm going back to the other question for those who need to screenshot. There it is. Chantal? Guys, please remember to mute yourself and then lower your hand once you've asked your question. Chantal, there should be a pop-up to unmute yourself.
Afternoon, ma'am.
There you go. Hi.
Afternoon, ma'am.
Afternoon.
Ma'am, can I please ask, if you don't write the reason, ma'am, is the answer wrong?
It's not wrong, but you will lose a mark.
Oh, thank you, ma'am.
Okay. So guys, if you leave the reason, you won't get the whole question wrong, but you will lose a mark. Right, Amatle?
Hi, ma'am.
Hi.
Ma'am, if we trying to prove that the angle the triangle is like equal, we write converse Pythag. And if we're trying to find, if we're trying to find the hypotenuse, we write Pythag.
Exactly. So if it says prove that it's a right angle triangle, the second you see that word prove, converse. If it's just find the length, then it's just normal Pythag. Really good. Well done. Good summary of the reasons there. Little, yes, it's just one mark that you lose. You'll lose a mark for your reason. Okay, guys, I hope we all have our screenshots here. Right, you guys have done really nicely. So I think you are deserving of a brain break. So let's give our brain break a try here. I know I should know the answer to this one, but that's fine. Right, you know how the brain break works. What we want to do is we want to work out the value of this final equation down here. When I see the first person to give me the right answer, I will let you know, and that person can raise their hand to let us know what the answer is. Normsel, you have to include a reason. So I'm not too sure why she didn't say anything, but it's a geometric, it's a geometry concept. Anything to do with geometry, you have to give reasons. So you do need to include it. Okay, so guys, we're trying the brain break. Let's give it a go. If I don't see any answers in the next like 2 minutes or so, I'm going to move on with the rest of our questions. Remember, you're trying to find the value of the cat, the goat, and the raccoon in order to get the value of your last equation. It's solving an equation. Like we do in algebra, solving an equation. Okay, Naledi, it's not 143. Ooh. Shauna, nice. I hope I'm saying your name correctly. So Shauna, if you want to raise your hand, was it Shanaz? Please correct me. 121, absolutely right. So if you want to raise your hand and explain it. All of you put in 121, and I hope you know how you got it, because I'm going to pick on you if we don't get our hand raised. Okay, Nokutenda, you want to raise your hand and explain? Amanga Sisi, the joke is there. It's the blue one, but I see what you're saying. Okay. Okay, so clearly some of you just put 121. Okay, so no Cortenda's not raising their hand. Kokoklano, do you want to raise your hand to explain? Mamelo. There we go. No Kotenda.
Hello, ma'am.
Hi.
Okay, so I got 121 by saying 12 divided by 3 gave me 4. So the one cat is 4.
Good.
Then I said 332 minus 8, which
Good.
gave me 324. Then I said 18 times 18, which gave me 324 plus 8, which gave me 332.
Nice.
Then I said 214 minus 18, which gave me 196. Then I said 14 times 14, which gave me 2 plus 18, which gave me 214. Then I said 9. Then I said 18 times 14 plus 9, which gave me 121.
Good. Sorry, it took me a second there. Well done. Okay, and guys, I really like that Nokutenda did the bod math there at the end. So remember, it's the 2 cats, which is 8, times the 2 raccoons, which is 14, bod math. So the multiplication has to happen first, and then only do we add. And that gives us our answer of 121. Very, very nicely done. Alrighty, guys, let's have a look at another question, hopefully another 2 questions. I'm about to scroll away from this, so I don't know if anyone feels they need a screenshot. I'm about to scroll. Alrighty, so I want you guys to try this one again for me. So remember, identify your longest side. If we have a look here, our longest side is the 25 units. Oops, okay, there we go. And let's use that in our Pythagorean theorem to see whether or not this triangle is a right angled triangle. You are trying it by yourself, so let's give this a go. And then we'll see what we get. Remember, answers on the chat. Let's see, guys. Oh, excuse me, everyone. Hey, trying this by yourselves. Thank you, Mnati. I don't know, there's clearly something in the air today. Remember, the goal is to prove left-hand side is equal to right-hand side. And just as another reminder, remember your longest sides, this 25, is substituted in place of h squared. Because that is what your longest side would be. Nice, grade 8s, well done. Okay, so if we substitute it in, we would have 25 squared is equal to 20 squared plus 15 squared. Remember our reason, converse Pythag. $25 squared is 625. 20 squared is 400. 15 squared, 225. So when we add our numbers on the right, 400 plus 225 is 625. And therefore my left-hand side is equal to my right-hand side. And so therefore it is a right angle triangle. And guys, remember, the whole point is to prove whether or not it's a right angle triangle. So you do need to actually make this last statement here saying, yes, it is, or no, it isn't. So yes, you need to say left-hand side is equal to the right-hand side, but you do also actually need to do what the question asked you. The question said, show through calculation whether or not it's a right angle triangle. So you actually need to go and say, yes, it isn't, or no, it isn't. Yes, it is, or no, it isn't. Sean, how many marks? So substitution, reason, showing that the left is equal to the right, and your conclusion. So anywhere between 3 and 4 marks. Leto, I don't really understand what your question is. You said, I'm sorry, you said we must use converse Pythag. Yes, because we're proving that it's a right angle triangle. Okay, guys, let's take our screenshots. I think we can squeeze in one more. Yes, and also remember, you push Shift-6 and you get the little arrow, and then you just type in the 2. That means squared. That means to the power of 2. All right, guys, next one. Okay. Right, let's try this one. Last one, you can do it. Prove whether or not it's a right angle triangle. Now, grade 8, really importantly, just because something looks like a right angle triangle, or just because something looks like it's parallel or whatever, doesn't mean it is. You actually need to go and do the calculations. And this goes back to someone's questions earlier. I can't remember whose question it was now. But someone asked, you have to show all of the calculations. Yes, you actually need to prove whether or not this is a right angle triangle. For all we know, this angle that looks like a right angle triangle is 91 degrees. If it's 91, it's not a right angle triangle. Right, so let's give this one a go. This is your last one. I'm going to give you 2 minutes. Let's give it a try. Remember, first thing you do, identify your longest side. Like what I'm seeing so far. Give you another minute. So remember, the question is it a right angle triangle or not? So make sure you do make that final statement. Nice, grade 8. Well done. This is excellent work. Alrighty, so we substitute in our longest side, which is 30. So 30 squared is equal to 22 squared plus 11 squared. If you said 11 squared plus 22 squared, that is also absolutely fine. Remember your reason, converse Pythag. Alrighty, 30 squared is 900. 22 squared is 484. And 11 squared is 121. If we then go and add 484 plus 121, we get 605. Now, what's really important is obviously those two sides are not equal to each other. So the left-hand side is not equal to the right-hand side. And because they are not equal to each other, this triangle is not a right angle triangle. And again, please remember to actually make the statement that it's not a right angle triangle, because that's actually what you have been asked. You've been asked to show, is it a right angle triangle? So guys, absolutely, as some of you asked, yes, sometimes they're not equal. That then means it's not a right angle triangle. If they are equal, it is a right angle triangle. You can definitely have fractions and decimals. It doesn't come up often with Pythagoras, but you can. Okay, there's nothing wrong with that. And just remember all of your reasons because it is a geometric concept. All right, so let's take our screenshots of the last one.